All right, so our learning goals are to learn how to solve problems involving either perimeter or area. You know, you put your mouse down. Recall the perimeter of a two-dimensional object is the distance around the outside. Okay? It's measured in units like centimeters, meters, feet, kilometers, etc. The area of a two-dimensional object is the number of square units it takes to cover the surface. So for me, when I use a highlighter, if it's perimeter, I just highlight the other edge. If it's area, I color it in. That helps me remember the difference between the two. For area, the units are centimeters squared, inches squared, meters squared, etc. Here's our first example. So get tracking. Ashley runs around the following track. How many times must she run around the track in order to run a total distance of 4 kilometers? Show your work, and it gives you a hint box. 1 kilometer is 1,000 meters. So first thing I would think about when I was reading this problem, before I even start making my plan, is it a perimeter problem or an area problem? Okay, perimeter, and she's running around the outside. Okay, so I'd probably take my highlighter, my pencil crayon, and go around the outside. Then I start thinking of a plan for the question, like how am I going to figure out how many times she has to run around in order to have gone 4 kilometers? How will I go about doing that? Vanessa?
You know that there's a little rectangle in the middle.
Yep.
And you know that that's one of the sides is 100, so the bottom side is 100 too.
Yep. So I know the two straightaways.
Mm-hmm. And then you can figure out the perimeter of the ends by using the formula for a circle.
Yes. So if I put these two ends together, I would get a circle. Yep.
And after you find the perimeter of the semicircle, since it's technically just one circle, then you would have to subtract 60 meters since
Okay, so this is what I'm kind of putting your two ideas together. So I'm thinking so far, we're thinking we're adding these two numbers together. We're not adding these into it. Oh, does everyone agree? They're in the inside. So I'm not adding those into it because she doesn't run this way, or she, you know, if it was a race, she'd really lose because she'd all of a sudden go off the track and run down here. I don't know how to get back on the track. She'd lose, right? So she's just going around this way. All right, so the two straightaways are 100 each, and I want to also add on the curved parts. I could find them each, like Ashley said, individually, but could I just find a circle and add on a circle there, and then I'd have the distance around the other edge? Okay, so if you look on your formula sheet, what's the formula for finding the perimeter, the outside of the circle? Daniel. Good. See, it's called circumference. C equals pi times diameter. So circumference, if you're rusty, is the perimeter of a circle. So C doesn't stand for circle, even though sometimes you think that when you're a kid. It stands for circumference. Okay? C, and circumference is the perimeter of the circle. So to get the perimeter of the circle, we put those two edges together. We pi times the diameter, which is 60. So 60 times pi is 188.5, approximately. So I'm going to add that over here. Agree to get the perimeter? I'm going to add those three numbers together. So my perimeter is going to be approximately 388.5 meters. Does that make sense to everybody? So what does that 388.5 represent?
One lap around the track.
One lap around the track. Okay, and I need to know how many laps she has to do in order to go 4 kilometers. Okay? Any ideas how I can figure that out? John?
You
So keep adding 3.5 till I get close to, that's one way. Glenn?
Divide 4,000 by 3.8.
Yes. So the number of laps is going to be the total distance I have to go, which is 4,000 meters. How did you know it was 4,000 meters, Glenn?
Because 1 kilometer is 1,000.
Right. Okay, so 4 kilometers is going to be 4,000 meters. Very good. So the number of laps is going to be the total distance I have to go divided by 1 lap. And when I divide those, I'll get the number of laps. .3 approximately. So 10 is not enough. He has to go a bit more than 10. And then we got to answer it. Ashley. So therefore, Ashley must run 10.3 laps. Okay, so the pitfall in this question for the year it was on EQAO was adding in the 60-meter sides. Okay, but you have to think logically. Never just rely on your formula sheet. Always rely on common sense. Then make your plan. Okay, because she does not run along those lines. She only runs around the outside. Okay. All right. Paint. Jackson is buying paint for his wall. 1 liter of paint will cover 9 square meters. How many liters of paint does he need to cover the wall? Justify your answer. So look through it, decide whether you think it's perimeter area, and then see if you can come up with a plan in your head of how you would go about doing that. Or if you don't have a plan for the whole question, what would you do first? Okay, who thinks they know whether it's perimeter area and why? Vanessa?
It's area,
Okay.
because he's buying paint for the wall and he's trying to cover the
Right.
area with that.
So there's my paint, right? I'm painting this, so I'm covering the whole wall with paint. Good, so it's area. So we've established it's area. So then you gotta think area, okay? So how might I find the area of this? There's a couple ways. Reese?
Well, you know the triangle is base times height divided by 2.
Okay, so you're gonna divide it into triangles?
Yeah, but
Okay.
you can't do that right now. You need to figure out what the
We got
height of it.
For a triangle? That's what you thought? It's on the sheet, Amelia.
Oh,
So then what I did is I realized that little tiny section that juts off of the triangle is 2.5 meters tall.
Yes.
So then I took that away from the 7.5 and
Yep.
got 5 meters for the height of the.
Nice. Okay, so Reese is going to divide his into a triangle and a rectangle and then add them together, which is lovely. So if you look on your sheet, if you look under area, if you look at your sheet here, it's divided into a perimeter column and an area column. And this is only if you need it. If you know them, you don't need to look at it, but you are allowed to have it all the time, okay, even if you're doing EQAO. So the formula for a triangle is base times height divided by 2. So Reese was saying, well, I need the base, but I do know the base because if the bottom is 12 meters and this is 12 meters. But the height isn't right written on there. I have to think to myself, I take the whole height, 7.5, and subtract off 2.5, and that gives me 5. Okay, so I've got my base being 5 meters. Nope. I've got my base being 12 meters. I'll just put numbers in and leave the units till the end. Height being 5 meters divided by 2 is going to give you 30 square meters. So that's the triangular portion. I've also got to do the rectangular portion. And that is one we all should know without looking at a formula sheet, length times width for a rectangle. .30 square meters as well. So then to get my total area, I'm going to add them. So I know I have to cover an area of 60 square meters with paint. So how am I going to figure out how many liters of paint I need if I know that 1 liter of paint covers 9 square meters?
Or you can divide 60 meters squared by 9 meters squared.
Good. So I need to cover 60 meters squared. So this is number of liters is going to be my 60 square meters divided by 9 square meters that 1 liter covers. And that'll tell you that you need approximately 6.7 liters of paint. So therefore, it will take about 6.7 liters of paint to cover the wall. Okay, so once you're confident you understand that one, what's the next one? You can come up with a plan. Okay, the perimeter of the track is 100.3 meters. What is the value of x? Interesting. Anyone have any ideas of something you could do? Reese?
Well, I'm just finding the circumference right now.
Okay, so you're gonna, we know it's perimeter, right? So are you going to find the circumference and then subtract it from 100.3? Okay, does that make sense to everybody? So I know my perimeter is 100.3. If I subtract off the circumference, so the circle part, all that's left is 2 x's. Does everyone agree with that for the perimeter? Okay, so whatever's left, if I divide that by 2, that'll be x. Make sense? Yes? Okay. All right, so I need the circumference in order to do that. So the circumference is 5 times diameter. Do I know the diameter of the circle? 16 meters. Oops. 50.3. 50.3 meters. Okay, so I'm going to subtract that off. Is that what you guys got, 50.3?
I got 50.27.
I got 50.2. Yeah, but if you round to 1 decimal place.
Oh.
Right? Well, if you use 3.14, you get a different answer, but I'm not going to quibble over 1 decimal place. Okay? Yeah, if this is an EQAO, it'll always be what's to the closest anyways. Right? Okay. All right, so minus 50.3. And EQAO, this is EQAO. They made it work out nicely because then when you subtract, what do you get? 50. Everybody get there? Meters. So the whole circumference, so if I go around the whole thing, it's purple here because maybe it'll go over. If I go around the whole thing is 100.3. But if I subtract off these end parts, now I'm down to just 50 meters. So I need the 50 meters to cover this X and this X. So how long is each X? 25. Perfect. So I need to take that 50 meters, divide by 2, 25 meters. So therefore, oh no, I don't think it's the multiple choice. So I circle 25 meters, which is D. Okay. Nice. All right, think about this one. Okay, it's area because it says so in the question. What would be your plan to find the area? Asha?
Find the area of the rectangle and then the semicircles and then subtract them.
Okay, so find the area of the whole thing. And then find the area of the semicircles. If there's semicircles, could I just find the area of the circle? Yes, okay. And subtract it from the area of the rectangle. Okay? So how do I find the area of the rectangle? Length times width. So I'm going to label it. So when you're doing an open response, make sure you're clear about what you're doing. So even if you make a mistake, people know what you were trying to do. So the area of the rectangle is 160 meters squared. We decided that if we put the two semicircles together, we're going to get a circle. Yep.
You can get the diameter of the circle by minusing 3 and 3.
Nice. Okay, so it doesn't tell us this radius. And if you look at the formula list for the area of a circle, it's pi times radius squared. Okay, so I need to know, as Austin said, first of all, I need to know the diameter, and then I need to know the radius. So Austin's idea was, I know this whole side's 20, okay, and I'm going to first subtract off the 3, the 2, and the 3, which is 3, 4, 5, 8. So I'm going to subtract 8. So I'm left with 12 meters. And it says the dimensions of the side of the bridge are shown. The arches are semicircles with the same radius. So what do I do with that 12 to get this distance here?
Divided by 2.
Good.
2 semicircles.
It's 2 semicircles. So 12 meters divided by 2 is 6 meters. So each one of these is 6 meters in length. That's the diameter, so what's the radius?
It would be 3 meters, but couldn't you also just do pi times the diameter?
No. You can't, because that's circumference. You want area.
Oh.
Okay, so that's why there's two sides of your formula sheet. Perimeter side is circumference, the distance around a circle. And then the area side is pi times radius squared, which is the area of the circle. So squaring something and multiplying by 2 are different, right?
Oh.
You got that? Yeah. Hi.
Unless it's 2, then it's the same.
Thanks, Mr. Jago. You are correct there. So radius we just figured out was 3. So pi times 3 squared, or pi times 9, is approximately 28.3 square meters. So now to get the area of the bridge, we'll call it bridge area, I need to show that I'm subtracting. Remember, you have to show your thinking, you have to show that you're subtracting, you can't just do that on your calculator and then all of a sudden come up with the answer. So determine the area of the side of the bridge shown, show your work. We did that, we found the area of the rectangle, we found the area of the circle, we showed how we got the diameters of the circle, we showed how we got the bridge area, now we just need a therefore statement. Okay? So therefore, the area of the side of the bridge is approximately 131.7 square meters. Five laps around the circular track is a distance of 637 pi. Okay, so first of all, that's an unusual number. Does anyone remember from the first unit what that means?
It means like that the number has a bunch of decimal places, so it's easier just to have pi percent, so it's more exact.
Yes, but if I wanted to know what it was approximately, it would be 637 times pi. Everybody good there? That's what it means when it's right beside. Okay, so it's like more than 3 times as big as 637. Okay, what is the radius of the track? So that's what we want to find out. Any ideas how I could find that? Reese?
Well, if you times 637 times pi, you could get
Decimal?
around what it was approximately.
Okay, so 637 times pi is about 2001.2 meters. Okay.
And then you can divide that by the number of laps. Figure out
Okay.
one numbers.
Okay, so 2001.2 meters, that's 5 laps. Okay, so if I do meters over laps, you guys can just divide, but I'm going to show a proportional way to do it. Meters over laps. So we want to know how long it is for 1 lap. Okay. There's a proportional reason you can also just divide by 5, right? But if you make it proportional, then you can do this. So 5x equals 2001.2 divided by 5. And you get 1 lap is approximately 400.2 meters. How does that help us out? So that's 1 lap. How does that help us getting the radius?
That's the circumference.
This is the circumference. So do we have a formula that circumference is? Yeah.
2 pi r.
Oh, 2 pi r. You see, does everyone see that one on your page? You could also use pi times diameter, couldn't you? And then once you've got the diameter, divide that by 2. Okay? This one is also, you could also use this one. This one, though, I replaced circumference with 400.2, because that's the distance around the outside. And radius is what I want to find. So what would I do to both sides, Atha, in this case?
You could divide.
Divide by 2 pi? Yes, I could. Just make sure when you're using your calculator, you put the 2 pi in brackets, okay? Otherwise, it'll divide by 2 and then multiply by 5. So you want to make sure you can get that into your calculator correctly. So 400.2 divided by bracket, opening bracket, 2 pi or 2 times pi, depending on your calculator, closing bracket, 63.7 I got. Meters. Okay, alternatively, we could have used the, if we're more comfortable with the pi times diameter formula, setup would be very similar, although we would just need to divide by pi. And we would get the diameter. And it would give us 127.4 meters. And then to get radius, you would divide that by 2. Which gives you the 63.7. So either the way that makes you feel more comfortable is the way you should use. Both of those ways will get you to the answer. Okay. We need a statement here. So what is the radius of the track? Therefore, the radius of the track is 63.7 meters. What are you looking at? Like, it's getting in your calculator properly? Which one are you doing? The diameter side or the 400.2 divided by second, and then that button equals. So that gives you the 127.4. And then divide that by 2 to get the radius. Vanessa?
There's one crucial way.
Yep.
7 divided by pi left, and then just divided by 2.
Yeah, that's because the pi's,
Yeah, and that's the diameter.
yeah. So that's, it's because the pi's cancel out. Yeah, you could, but you should leave it as 637 pi, not 637.
Because diameter pi,
Right.
so that's the diameter.
I'm just saying you would want to show that in your calculation, okay? You want to keep the pi in your calculation and then just cross them out when you divide, okay? Amelia. Calculator?
I like to.
Okay. Which one are you doing? 400.2 divided by 25? Okay, so 400.2 divided by, opening bracket, 2 times pi, closing bracket, equals. Okay? All right, look at the next question and see if you can, this is a tricky one. Okay, do you think this question is an area question or a perimeter question? Reese? Area. And what clue in the question told you it was area?
It says here. So, it's talking about how they both, the two specials contain the same amount of feedstock,
Yep.
which I thought was area.
Okay, so because it says that they're the same thickness, we don't have to worry about the volume, right? So they're the same thickness, so we don't have to worry about volume. So then we can just worry about the area here, okay? So basically, the area of these two is equal to the area of this one. Does everyone see that? So our technique is going to be the area of these two together is equal to the area of this one by itself. Okay, equal areas. So can I get the area of these two pizzas? How can I answer?
Well, you can find the area of one and multiply by 2.
Okay, I can do that. So the area, so what do you want to call these ones? Fibonacci? Fibonacci, always label your work. And we know it's a circle and we're finding area, so there's our formula, pi r squared. And can I put in a times 2 since I know that I want 2 pieces here? Yeah, that makes sense. Okay. So what is the radius of the Fibonacci special here? You know, yep, 12.5, good. So radius is 12.5 squared times 2. And I should be able to put that into my calculator all at once. So I want to do pi times 12.5 squared times 2. So the area is approximately 981.7, and they're in centimeters squared. So those two pizzas together have a combined area of 981.7 square centimeters. How does that help me get the radius of the big pizza? Reese.
So if that was 12.5 for the radius, and the diameter is 25,
Yep.
and this pizza contains the same amount as these two put together,
Yes.
then that would mean that the diameter is going to be 50 centimeters.
Do you think so? So I can test that out real quick. So second pi.
Well, I did the math and it didn't add up.
Okay. So because what you're thinking is that it's a direct linear relationship, but it's not. It varies by the square of the radius. Yep.
Well, you can rearrange it and make R the subject with the area formula.
That's very good, Asha. You can definitely do that. So the area, do we know the area of this big pizza here? Yes, what is it? 981.7? Everyone good? It's the same as the area of those two pizzas. So if I look at this as an equation, what's the only thing I don't know in this equation? Radius, good. So if I want to get radius by itself, what would be the first thing I would do to both sides? Got a choice between two. Vanessa. Divide by pi. Good. Reverse goodness when you're solving an equation. So 981.7 divided by pi is about 312.5. That's equal to the square of the radius. Then I want plain old radius. So what would I do to both sides? Yep, square root, lovely. So then we end up getting radius is approximately 17.7 centimeters. That's the radius, but be careful. They want the diameter of the Galileo special. So if I know the radius, the diameter is going to be 2 times the radius. Which is approximately 35.4 centimeters. Okay? Nice. Okay, so then we need a nice concluding statement. So therefore, the Galileo pizza would have a diameter of 35.4 centimeters. Nice. Okay, once you're done this one, look at the next one and see if you can come up with a plan. If not a plan. Okay, so when I see the word perimeter, I'm going to go around the outside of the shape. And make sure that when I'm doing my adding up, those are the only, I guess, 3 sides I would add up. The 8, the 6, and the semicircle. So how do I figure out this distance here? Reese.
You would well, circumference equals pi times the diameter.
Yep,
And we know that the diameter is 10.
yep,
So then we just do that.
awesome,
And you should get 31.4 feet.
yep. 31.4 feet. Now that would be if it was a whole entire circle, right? So what's just this part here? What would I have to do to just get this part here? Divided by 2. So 31.4 feet divided by 2. It's still approximate because I use an approximate number to begin with. Gives me approximately 15.7 feet. So this curvy side, as I call them, is 15.7 feet. So now I know all of the three sides, I'll call them, even though this one's a curved run, right? So if I know all three, I can just add them up. So I've got 8 feet, 6 feet, and 15.7 feet. I'm adding them because it's perimeter. So the perimeter is about 29.7 feet. And it says to the nearest tenth of a foot. Okay? Now, how many people added in the 10 feet when they were adding up for perimeter? Yeah, okay, so again, all highlighting the edges helps you. Don't just rely on the formulas as well, because it will tell you to add all 3 sides for a triangle. But again, for composite shapes, perimeter is just the outside. Okay, you can't include any inner lines when you're doing perimeter. Okay, it's just on the edge, outer edge. So always reflect back and make sure you're just using the outer sides when you're doing your addition then. Okay? All right, we'll give you a chance to try this one. Okay, so if I knew it was perimeter, I would highlight around the outer edge. And I kind of think, okay, I know this side, check. I know the bottom, check. This side, this piece here. So the only side I don't know if I want to find the perimeter right now would be the semicircle. No, it's perimeter. Yep.
I don't know if it's right, but I did the whole line, I did 20, 20, 7, 7. I found the perimeter of the rectangle.
Yep.
And I took out the semicircle. And then, but I couldn't find the circle because not full circle, it's the semicircle.
Okay, so we're not going to include this 10, because then we just have to subtract it. So I like what you're saying, that let's so far show what we got. So we've got the 10 meters here, and the 7, and the 20, and the 7. But John's saying that there's something that has to be here that represents this, right? Okay, so if I find the circumference of an entire circle, which I know the diameter of, I should divide that by 2, and then I'll have, does that make sense to everybody? Okay. 31.4 meters approximately, and then 31.4 meters divided by 2 is approximately 15.7. So that 15.7 meters I have to add up. And then that should be my perimeter approximately, because the 15.7 is rounded. So 10. I add up both sides, I get 59.7 meters. Does that make sense to everybody? To get the perimeter, you haven't answered the question yet, but that's how much fencing we need. We need this 10, plus this 7, plus this 20, plus this 7, plus this 15.7. And then we fence the whole thing. Okay? Any questions so far? All right, now it costs 550 meters or sorry, $5.50 per meter to fence it. So how do I figure out how much it costs for the fencing? Yep.
Add the two numbers together, and then multiply by 5,000.
The two perimeters, I've got perimeter, total
Oh,
perimeter.
yeah. Okay, well then multiply by 5,000.
Okay, so $5.50 times 59.7, that gives me the cost of the fencing. So that means it's gonna cost $328.35 before taxes, this is before tax, to buy the fencing I need. And then who remembers how to do tax? Yep,
To find the tax, you can multiply by 0.15, then subtract that from
yes, and or do I go back to percents, whatever you want, I'm not picky here, but here's my 15%. We go back to proportions. Our total price so far is $328.35, and we want to know how much the tax is. So we can do our proportion set up for us. Cross multiply. $49.29 tax. And then if that's my tax, I add it on. Everybody good? So total is going to be the $328.35 plus the $49.25. Which gives me $377.60. So therefore, total cost of fencing would be $377.60. Okay, if you have another way to do tax, that's fine. However you want to do it, as long as you can get the 15% added on to the total. Okay, the next question, area of a trapezoid. I'm going to do together that we have to find. There should be a question mark there.
Oh.
Okay.
Norfolk can stay with you guys all day. She would need to find. She would know.
Okay, what is the area of the trapezoid? So, you have a formula on your formula sheet. For trapezoids, do you see it? I'm just kidding. And it looks like this. Oops. Everyone see it on your sheet? Okay. Now, has anyone done your trapezoid before? Who hasn't even heard the word trapezoid before? Everyone heard it? Yeah? Okay. I don't know if you covered grade 7 and 8. So a trapezoid is, I'll just do like a brief, you can draw them in many different ways, but basically they have one set of parallel sides, four-sided figure with one set of parallel sides. Okay, so I can have, this is a trapezoid, if these are both right angles, because that makes these sides parallel. Okay? Now your parallel sides are always your A and B. It doesn't matter which one you call A and which one you call B, but your parallel sides are your A and your B. Okay? The distance between them is the height. The distance between the parallel sides is always the height. So those are the three letters that are in your area of a trapezoid formula. Okay? So if we look back at this one, oh, it's break. Start to work on here. So its area, it's a trapezoid. Here's our parallel sides, because these are 90-degree angles. So we know A and B. But do we know H, the distance between the two sides? No, we do not. Any ideas on how we could find out it? Johan?
Pythagorean theorem.
Pythagorean theorem. So I can make a triangle here, right? And there's my right angle. So that makes this side C. This is the side I want. How can I figure out what this side is? Johan?
1 minus 14.
20. So this whole big side, take away the 14, gives me 6 meters. Okay, so I can do the Pythagorean theorem. So I'm going to say, put this, I'm finding the height right now. So C squared equals A squared plus B squared. 16 squared equals A squared plus 6 squared. 256 equals, I can change A to H if I want, H squared plus 36. And then to get H by itself, I first need to subtract 36 from both sides. $220 is H squared, but I need H, so I need to square root both sides. So that gives me H to be approximately 14.8. 14.8 meters. So now that I know that, I can use this formula for the area of a trapezoid. So I can put 14 in for one of the two parallel sides, A, plus 20 for the other one, times the height, which is 14.8, divided by 2. And then I would add the 14 and 20 next, so that's 34 times 14.8 divided by 2. Figure that out. Remember, it's approximate because I rounded the height. To 51.6. And then units are so important in measurement questions. It's area, so it's square meters. And then therefore, the area of the trapezoid is 251.6 square meters. So there's a lot of problem solving in this, okay? Basically in grade 9, it's assumed that you've done area and perimeter already in previous years, okay? So basically you're distinguishing between them, solving a bit more challenging problems than you did in grade 7 and 8, okay? Sometimes money will get added on, or the number of laps, things like that. So basically deciding if it's perimeter or area, planning out a strategy, executing it, Okay, and if you're having trouble, then you can ask, for help from them. Okay, I'm just gonna pass out the practice. Yep, from it. Yep. About this one?
And I got
Did anyone else get 251.6 or did I put something in wrong? I got that. You got what?
I got you.
Just try taking it in again. 34 times 14.8 divided by 2.